End of the day. Last 2 classes of the day, and you got to spend it all with me. Sorry about that. Just works that way sometimes. Okay. We've covered a lot of new materials in just a few days. What is the big topic that we've been talking about for the last 3 days? Limits. Very good. And we have discussed 3, well, what is a limit? Let's put it that way.
A limit is the estimated point at which a point is on a graph. Estimated point, okay.
When x approaches a certain point, it's the estimated point that y would be.
Okay, it's when x is approaching a particular point, it's the point that we estimate y will be at that time. Anybody got a different way of saying it? I like the word expected value. It's what we expect it to be. Estimated, okay, we expect it to be that value. Basically saying the same thing. How can we figure out what a limit is? Got 3 ways. Mr. Wells.
We can look at the graph.
Look at the graph. Algebraically. Numerically, okay? What does numerically mean? Look at the chart. Look at X, Y numbers. Look at those kind of things, okay? Algebraically means do math, right? We do some factoring. We do something. We do something that feels mathy and makes us feel like we're doing math. So today we're going to continue with just the last few problems in O2. We didn't quite get finished with all those yesterday. We're going to do those. Now, I need an update on where you are. I think everybody's turned in homework 01. I believe one person had not turned in homework 02 yet. Excuse me, one person has turned in 02, I think, so far. So, and you're right, I told you not to do, so that's okay. And we have a web assign that we're working on right now, okay? By Monday, we are going to have done homework 01, homework 02, homework 03, and web assign 1, okay? So that's kind of the rest of the map out here between now and Monday of what we're going to try to accomplish. So right now we're going to pick up with this problem, which looks like is about slide 11 or 12. And we are evaluating these algebraically. Mr. Douglas, did you get an opportunity to watch our stimulating class from yesterday?
Not thoroughly.
Okay, all right. Well, you can just jump in and see if you can hold on. Just try to, and then during help time today, I'll sit down and go over everything we've done with you one-on-one. So, when you look at this problem, we could graph it. We're still in the notes. Still in the notes. We could graph it. We could do a table set, but we feel better, and really it's best for you to do some algebra to it. So now, we said anytime we're trying to evaluate it algebraically, what's the first thing we do? Plug in what? 5? Yeah, the C. This number right here, we're going to plug that number in, 5. And when we plug 5 in, one of 3 things is going to happen.
You're going to get a whole number.
Whole number? And what happens if it's a whole number? You stop. Happy dance. We're finished, okay? Or 0 over 0, what's that called? Indeterminate form. And if we get 0 over 0, what are we going to do? Then we're going to do some algebra. We're going to do something there. What's the third thing that could happen, Macy? A number over 0, right. And if we get a number over 0, we know what? Right, we got it narrowed down to 3 choices in infinity, negative infinity, or does not exist. And how do we determine which of those 3 options it is? Plug in numbers close to it. How do we know if it's infinity? Okay, but now y'all are doing this, and I've never seen a number do this. Okay, so if you look at the graph, it's doing this. But what if you plug in numbers? What's happening? They keep getting larger and larger on both sides of it. What if it's negative infinity? What are the numbers going to do? They keep going down. What if it does not exist? One's going up, one's going down. Okay, so good. We've got all that squared away. So if we plug in 5 here, which of our 3 options do we get? A number over 0. Okay. What number do we get over 0? -2. All right. So we plug in 5. We get 2 minus 4 over 0. That's -2 over 0. That tells us that we've got 3 choices for our answer, right? Infinity, negative infinity, or 0. So how do you want to determine which of these 3 it is? Are you going to graph it, or are you going to plug in numbers close to it? I like graphing too. So if I were you, I would pull out my handy-dandy calculator, and I would graph this puppy. I am going to pull out my Desmos calculator. And I am going to graph square root, what was it, x minus 1 minus 4. Yes. That's what I would do. If you want to do it on the calculator, you could just do a screenshot and do that. If you actually do it on your calculator itself, you could take a picture of it and put it over there. I would just do something to put in my notes so when you're studying for this 6 months from now, you won't say, how on earth did I come up with that answer? You'll know. So we are wondering, we are concerned about what happens to this around the number 5. So when we look at this graph at 5, what do you think? Does not exist. When you look at the graph, how do you know that it does not exist? Right. One line is going increasingly higher to infinity. The other side is going increasingly lower to negative infinity. Therefore, we can conclude from this that the limit does not exist. Okay? Any questions on that there? All right, let's move on now. We have, this doesn't happen very often, but these are 2 things you need to memorize in here. You don't need to ask questions about why does it work this way. It will only make your brain hurt. Just accept that someone smarter than us has proven that the limit of sine x over x equals, as x approaches 0, is 1. All right? If you want to make your head hurt, let's come over here and let's graph this thing. If we graph this, we get y equals sine of x divided by x. All right? There's our graph, and it looks like it is approaching, that's right, we can't do that. It looks like it's approaching the number 1 if we look at the graph, okay? So we're just going to accept on faith that any time we see something like this, sine of x over x, that limit is equal to the number 1 if we're talking about the limit as x approaches 0. Now, I want to show you some variations on that so you can feel a little better about it. What if we've got the limit as x approaches 0 of the sine of 3x over 3x? It's the same thing there, okay? The key components for you here is this is going to 0, and these 2 things are identical, meaning they're the same thing, okay? So they have to be the same thing. If they're the same things, then we can say that this limit is going to be 1. The same thing holds true for the second trig limit there, 1 minus cosine x over x. That limit, as x approaches 0, is always 0. Don't ask questions. We can't prove why it is. That's above our pay grade at this stage in our life. We can't do that. But these are just 2 things to memorize. So you take a screenshot of this and store it somewhere, or just tag it somehow. Know that you're going to have to come back to this at a later time and utilize these things. The limit as x approaches 0 of sine x over x is 1, and the limit as x approaches 0 of 1 minus cosine x over x is 0. What if x is approaching pi over 2? Does this hold true? No, why not? Not approaching 0. What happens when I put pi over 2 in here? What's the sign of pi over 2? Ooh. It's 1 whole. It's 1. The sign of pi over 2 is 1. So it would be 1 over the pi over 2. Anything other than 0 we plug in there, we should wind up getting something that we can evaluate out of it, okay? But at 0, we cannot evaluate it because we get 0 over 0, the indeterminate form. So memorize those two. I'll quit boring you to death with it there. Yes, Dr. West. You can unify. Because the sign of 0 is 0, and 0 is 0. That's right. Yeah, yes, there's the conundrum. What are we supposed to do when we get 0 over 0? We're supposed to do some algebra to it, right? We don't have any algebra we can do with this. Okay? We can't factor the sign out. We can't multiply by the conjugate of anything because we don't have a conjugate of anything to multiply by. So all of our algebra rules will not allow us to solve this. The best we can do is we can look at a graph and say, it looks like it's going to the number 1. So this is a special trig function that we can't, a special trig limit that we cannot get an answer for algebraically. So we've proven that it's true. If you want a little light reading sometime, go read something called the squeeze theorem in calculus, and it'll explain to you how we prove that gets there, okay? I haven't been able to figure it out yet, but maybe y'all can figure it out and tell me how it works there. But truthfully, what you need to leave here with today is knowing that if I see this, that limit is 1. And if I see this, that limit is 0. And if you graph them, your graphs should support those things there, okay? All right, is that confusing enough? Oh, good. Oh, good. Now let's look at this. Then what are we going to do here? The limit as x approaches 0 of sec 2x. Secant 1 over cosine. Very good. First thing I am going to think about is, yes, there's no sec button on my calculator, so I am at a loss. So I have to do this. I have to rewrite it like that. Now, when I rewrite it like that, I should get somewhat happy because I'm going to have 1 over something, aren't I? So I'm going to get an answer. I'm not going to have to do any algebra to this here. So when I evaluate this, I'm going to say it's 1 over, what's the cosine of 0? Anyone remember? Yes, it is. The cosine of 0 is the number 1, so we get 1 over 1. Okay? And how can you know, if you're like most seniors, you aren't real sure about your trig stuff because you only used it for a few months and you're uncomfortable with that. What could you do now to verify that that's the right answer? Or to give you a little bit more confidence that that's the right answer? Graph it. If you were to graph sec 2x, how on earth do we graph secant 2x? Yeah, we can graph 1 over the cosine of 2x, and we should find out that limit, as we are approaching 0, is the number 1. I think you also had it in homework 1 or 2 somewhere, that a problem, either that problem or one very similar to that, okay? All right. How do we feel there? Okay, I want to spend a few minutes talking about 3, only because it's not really anything new. It's just a little bit more funny-looking stuff from what we've already been dealing with. So if you haven't downloaded O3, You can download O3 for just while we're talking here. And as I said, these are all solving these limits. We're solving these algebraically. The difference being some of these have funny symbols in them. Yes, and we don't like those funny symbols. Why don't they just use letters somewhere? I mean, what do we need triangle letters in here for? I mean, that doesn't make any sense. But trust me, there is some value to being able to use these, and you're going to see it in the higher mathematics courses that you're all going to take because you're such brilliant people. So you need to get accustomed to it. What do y'all read this triangle X? What does that mean to you? Change in X, delta X. Okay, you'll hear me call it delta X. And it means the change in X. It means we're changing X by a very small amount. Delta X is not two separate symbols there, okay? It's one thing. So you treat delta X as its own variable there. It's just like a Y or an A or B or any other variable you might have there. It's just its own variable there. So what happens when we're looking at this? What happens when we put 0 in place of delta X, not X? We're putting 0 in place of delta X. We get X squared minus X squared over 0, which is 0 over 0, right? We get the indeterminate form, 0 over 0. So we need to do some algebra. So what algebra do you think we ought to do? Wow, you could do a couple of different things there, depending upon what you see. There's perplexed looks around the room. What can we do algebraically? Can we square? Do you mean that? You could. I don't think that's going to get us anywhere good. Introducing square roots is not something that I would recommend here. What algebra do you see here? You can multiply it out. Okay, that's fine. You should be able to, with your mathematical knowledge, you should be able to take that right there and square it out. So, do you know what I mean by square that out? X plus delta X times X plus delta X, first, outer, inner, last. So go ahead and multiply that out and see what you get. See what happens. The worst thing that can happen is you waste 1 minute writing it down and find out that it doesn't work. Well, I am sure that you may be feeling thoroughly lost right now in what we're talking about because you're coming in midstream here. But just know that what we're doing is we're doing some algebra to this.
Yeah, I understand. I'm just trying to figure out if I was doing what you're planning to do already.
Okay.
But
Okay, good.
figure out how to figure out that.
All right. Well, how are we going to work this out? So let's see. We've got X plus delta X times X plus delta X. You may need to write it out. If you remember your Pythagorean triangle, not Pythagorean. If you remember, it's not. Who is it? It's not Pythagorean. It's Pascal. That's the one. If you remember Pascal's triangle, you may be able to do it that way. If you are a cheerleader, you may remember the cheer, the square the front, square the back, twice the product of the two, and that gives you something to it there. However you multiply it together. But I'm going to multiply first times first and get X squared. Outer gives me X delta X. Inner gives me X delta X. And last gives me delta X squared. We didn't do anything with the X squared after the subtraction sign. And we didn't do anything with the delta X in the bottom. Now, you may have X squared plus 2X delta X plus delta X squared. That's the same thing because I can add my two middle terms and get to that point there. But that's what I see to do there, to square that out and see what happens.
difference of two squares?
Very good. I was wondering if anybody was going to see that. Yes, you could do the difference of two squares, Dr. Lee. You could have said that's x plus delta x plus x, and that's x plus delta x minus x. Do you see that he factored out, he took this top thing and saw it as something squared minus something squared and just factored it. And you'll get to the same place there. So either way that you worked it is all right there. I'm going to continue working in the blue area, and we'll pick up with the green in a moment and figure out. So, all right, we've squared this out. What do we need to do now? The x squares cancel out. And don't forget to write your limit notation, okay? It's important to write down the limit delta x approaches 0. When can we stop writing limit delta x approaches 0? When we plug that 0 in, okay? Now, I'm going to do two steps here. I'm also going to clean up a little bit what's left in the numerator because I have two terms that are the same. 2x delta x plus delta x quantity squared. So I've done some algebra. Can we pull delta x out of all of it? On the top, you mean? Yes. Yes, you can factor out a delta x in the numerator. I think that's a wise thing to do. If we pull out a delta x, Ms. Sims, what do we have left if we pull a delta x out? 2x plus delta x, which is going to become 0 here in a moment. Yep, she's 2 steps ahead of us, which is fine. Means you're smart people. And now once we get to this point, your brains are already churning. You're already doing the happy dance because you see, oh, these are going to cancel. I don't have a fraction anymore. I can plug in and I can get an answer out. And the answer is no. What's the answer?
Oh,
2x. Yes. All right. The answer is 2x. Why isn't the answer just plain old 0? Right. We're putting 0 in not for x. We're putting 0 in for delta x. This puppy here becomes 0. The 2x doesn't change. We don't know what x is. All we know is what delta x is. Delta x is getting really small. And to just show how smart you're going to be, in a matter of about 4 weeks, you'll be able to look at that problem and know that the answer is 2x. Yes. You can impress all of your friends with your massive knowledge at that time, okay? 2x is the answer there, okay? So how do we feel about that? Did that get us lost anywhere? All right. Good. Let's see if we can get you lost over here. But in 4 weeks, you'll be able to look at this and know the answer is 2x plus 2. Excuse me, 2x minus 2. My apologies. So suffer with that for a moment. All it is algebra. Just do some algebra. I think you want to approach it just like we did the last one. It'll only take up about a page there. And you should get 2x minus 2 for a final answer, if I did that right. Yeah, I cleaned up. I went ahead and squared the first binomial and distributed everything through and got rid of all my parentheses. So once you get to that on your paper, I recommend you look up here and see if you agree with what I have written down. I'm trying to determine if I agree with it or not, because that's the hard part right there. And if you don't agree, I recommend you look at it again or let your neighbor look at it and see if y'all can reach a conclusion on what's happening here. Because hopefully, say that, where you at? The final answer? Yes, the final answer should be 2x minus 2. Have you gotten there? Very good, very good. Yes, ma'am? Yes. Couple of things that people often forget to do. When you're distributing here, you're distributing a -2, so sometimes students will miss the sign on this delta x back here, the -2 delta x. You're also distributing a minus sign to the last 3 terms, so oftentimes people will miss some of these 3 signs here. So those 4 sign mistakes are what people will oftentimes make when working a problem like this. Just remember all the way back to Algebra 1. You're distributing negatives, so let's see what happens there. And once it gets there, I think it's pretty straightforward. You can cancel, I think about 3 things look like they cancel out, and I bet you can do kind of like what we did last time and factor out a delta x, and then poof, the answer just will fall into our lap. Let's see if that works. So we have the limit. I have 2x delta x plus delta x squared minus 2 delta x all over delta x. I must warn you that the exam that the little exam you take in May has 6 free response questions. That means those of us that are writing challenged must learn to write legibly if we expect to do well on the exam. So those of you whose writing is worse than mine or no better than mine, get in the habit of slowing down and writing clearly and showing your steps carefully. The limit as delta x approaches 0. I think I can take a delta x out now. I'll have 2x plus a delta x minus 2. And just like before, this delta x will cancel with this delta x. What happens to the delta x in the parentheses, though? It's just 0. Because once we cancel those out, we see that delta x is 0. We can plug it in, so we get our final answer of 2x minus 2. How do you feel about that? Was that wasn't too hard, was it? Okay. These are getting on towards the challenging problems dealing with limits here, okay? Challenging in that there's a lot of algebra mistakes that you could make there. We have some very good thinking problems here in just a moment, but these are good mistake possible problems. All right. See what you can do with that. The 1 minus cosine x over x, isn't that something? I don't think it is. It's the 0 one, okay? Yep. She's going back and remembering that we talked just a few minutes ago and said that this is equal to 1 and this is equal to 0. So the limit's 3. Yes? What?
1 minus cosine x is equal to sine x. So sine x, 3 sine x over x is equal to... No, it has to be squared.
Yeah. 1 minus cosine squared is equal to sine squared. No, I think this part right here looks very much like this second trig identity we had to learn that we showed you a while ago. So I think you can utilize that to help solve this limit. So what do you think the answer should be then? 0, 0, 0, 0. Okay? Because this limit, if it were just this, if this were our problem, 1 minus cosine x over x, that limit is just 0. We know we're accepting on faith what somebody said back there a while ago. Well, how does this 3 change it any? Tell me what's happening between the 3 and the 1 minus cosine x over x right now? We're being multiplied, right? So does it make sense that if we take this limit and multiply it by this limit, we should get the right answer? I mean, we're just multiplying two things there. Well, we know that this limit is 0, right? What's the limit as x approaches 0 of 3? Very good answer. It doesn't matter if you multiply it by 0, you're going to wind up with 0. But just for argument's sake, what is it?
So, since the limit is 3.
Why?
Well, you can't plug any numbers.
That's right. If we're trying to evaluate this algebraically, what's rule number 1? Plug in. There's no place to plug in, is there? It's a constant number, 3. What would it look like if we graphed this function that's just 3? It's just a horizontal line across there. So what's the limit everywhere? 3. It's going 3 everywhere. So the correct answer for this problem is 0. 0 was what that limit's going to be there. Very good. And we have to go back and use our special limits in order to do that. Why is this limit 0? Yes, the final answer is 0 because the limit of just this piece right here is 0. I think what you were trying to say was 1 minus, that's right. You were trying to say that 1 minus cosine, we could put sine in place of it, weren't you? And we can't do that. 1 minus cosine squared equals sine squared, but 1 minus cosine does not equal sine. So that was a mistake you were making there. So the final answer here for this one, this March 66, is 0. All right, move on to the next slide and let's suffer with it for a moment. I'll give you a moment to come to some conclusions on your own if you can and get to an answer. Yes, sir. Okay, that'll be okay this time. In the future, just take a picture of it and stick it in there with it, okay? Yeah, that's fine. That's fine. Just take a picture, and that's so I can see where you made any mistakes, but also so you've got it for later on to refer back to. Okay. All right. What you thinking here? 1. Boy, those sound like confident ones. Trig identity. Oh, my goodness. Y'all know your trig identities. Very good. Very good. Well, what trig identity did we use then? Tan is sine over cosine. Okay. All right. So we can, in place of tan, we can make it sine over cosine, and then cosines go away, and we are at the limit as theta approaches 0 of sine of theta over theta, which we know from about 15 minutes ago is the number 1. Boom. There we go. You've got to go back and use those trig identities there. Did y'all like trig identities when you had them?
Oh, I haven't learned it. I haven't even learned it.
You did? Oh my goodness!
I was taking those at the same time.
Okay, you're going to have to ramp up. You're going to see a good bit of trig here, Kevin. So as you have questions, ask me about it. Okay? Does this? Have you seen? This is a trig identity. This tangent function can be replaced with sine theta over cosine theta anytime.
Oh, so that's the way to memorize those.
That's right. That's a memorization. If you'll look on Moodle under the class helps, there's a trig identity sheet or something right there. You'll probably want to memorize some of those. Okay, so what about this? The limit as phi sec phi. I think that's what that letter is. It's not pi. Is it phi or is it? I think it's pi. Okay. The limit as phi approaches pi of phi sec phi. Where do you start? Plug it in. We know secant is 1 over cosine. So we've got phi approaching pi. We've got phi times 1 over cosine of phi. And I should know now that I don't have to do any algebra because I'm not going to have a 0 on the top, am I? I'm going to have pi on the top. I'm not sure what I've got on the bottom yet, but I've got pi on the top. So I've just got to figure out what is cosine of pi. Tell me, how do y'all figure out what cosine of pi is? Okay, you can't use a calculator next May to figure that out. So how are you going to use it when you can't use your calculator? If you remember your unit circle, okay? If you remember your unit circle, do most of y'all remember something called the unit circle? Okay. Okay, unit circle. This is 0. This is pi over here. The coordinates of that point are 1, 0. This is 0. No, it's negative 1, 0. Yep, negative 1, 0 over there. Okay. And remember, on a unit circle, the first coordinate is what? Is it the sines or the cosines? First one is the cosines. So that says that the cosine of 0 is the number 1, and the cosine of pi is the number negative 1. So we know we've got pi over negative 1, which is negative pi for our final answer there. What is this second coordinate out here? That's the sine. So how could I find the tangent of 0 by just remembering that? It's sine over cosine. It's 0 over 1. Remember we wrote a while ago. Tan is sine over cosine, so it's 0 over 1, which is 0. And there's a unit circle in your class helps folder if you want to look back at it. But basically, if you can memorize this quadrant, if you can memorize those 5 or 6, I think it's 5 of them for that quadrant from 0 to pi over 2, you can get all the others there. So just be committing those to memory if you haven't done so already. Okay, we're not going to take a whole lot longer. Y'all can handle that. I'm not going to waste your time. This is the one I want to get to. This is the one that, this is the challenger here. Huh? I am. It's exciting to see this, okay? This is the one that's fun here, okay? There's not a lot to write down. There's just a lot to make your brain hurt here, okay? So, if I plug in 0, I get 0 over 0. So I need to do some algebra. But there's not any algebra that we remember to do for something that's just a sine of 2x. Look at the hint that they gave us out here. Does that do anything other than confuse you? Which one? All right. She says, that right there is just 1, okay?
And then when this
Is that 1? Why? Why not? Why not? Do you think it's 1 or not? Why not? It's upside down? So when I turn a 1 upside down, it's not 1?
No.
It is. If I turn a 1 upside down, is it still 1? But if I turn it upside down again, it's right side up. So what do you think it should be? Do you think this should be 1 or not? Okay. So, all right, let's think about this now. I want you thinking algebra here, okay? This is a fraction that's equal to 1, right? If I turn the fraction over, what should it do to this answer over here? It should still be 1, shouldn't it? Okay? So now let's look at what we have here, because we don't have an answer yet, but we've got some stuff that we can kind of throw away at maybe. Let's be sure we understand why the limit as x approaches 0 of 3x over the sine of 3x is 1. Let's go back to this right here. We all agree that has to be 1 because that's just looking at the trig limit that we looked at a while ago. Think of this algebraically. This is a fraction. The fraction is equal to 1. If I've got a fraction that's equal to 3, if I turn that fraction over, what's it equal to then? 1/3. Just turning the fraction over should turn the answer over, okay? So if I turn this fraction over, which is really what I've done here with the 3x and 3x, because remember, these two things are the same, so the same rule applies. That limit is 1 now. Okay, so we know then that the limit of this is 1. We know that the limit of this is 1. What do these things do to it out there? 2 over 1 and 1 over 3. So we get a final answer of 2/3.
Then we just have taken out the sine x in the first part.
Algebraically, no. You can't just pull that 2 out there and pull that 3 out there and say, there it is. Is it going to work? Yes. But you can't algebraically do it. The question I really want answered is, how on earth did they come up with this hint out here?
Is it 1 over sine x on the other side? Like, can you, reduce that?
Can we reduce it?
No, can we just multiply it by 2 over 2 and 3 over 3?
Exactly. Look at what they did. Look at the beauty of this mathematics, okay? I used to make students think very bad things about me because I'd give them a problem like this and say multiply by 1. But that's all that you have to do to solve this problem. Because what did we do? We multiplied it by 2 over 2x and 3x over 3. Right? Because isn't all of this stuff right here, isn't that just another name for the number 1? So I haven't changed anything by doing it because the 2's will cancel, the 3's will cancel, the x's will cancel. Everything in this blue box is just another name for 1. So all we did is multiplied it by the number 1. So we didn't change anything in it. But by doing that, we could put it in a format so that we can see that we have the limit as x approaches 0 of 2 over 3 times the sine of 2x over 2x times 3x over the sine of 3x. Why did I choose those numbers? Good question. Why did I choose the 2 and the 2x and the 3 and the 3x?
Because they're the numbers in the column.
That's right. They're the numbers that are here. Okay? It was 2 and 3. If it had been the sine of 2x over the sine of 5x, what would the answer be?
2 over 5.
2 over 5. Could I have multiplied by 3 over 2x times, what did you say? As long as it's just a name for 1, that's the crucial thing there. As long as it's a name for 1, okay? But I want you to see the beauty of this, okay? Because I do think it makes for beautiful mathematics there. I want you to remember that if you see something like this, the limit as x approaches 0 of the sine of pi x over the sine of the square root of 2x, what's the answer?
Pi over -2.
Square root.
Well, pi over the square root.
Pi over the square root of 2. I want you to remember this. That's the answer to this problem. Does it work with cosine? Good question. What do y'all think? What do you mean by cosine?
Like changing sign to cosine.
Like if this were cosine of 2x over cosine of 3x? That's right. The identity is not there. And also, what is the cosine of 0?
A number.
It's a number. So therefore, it wouldn't because of that. Then you could actually evaluate it. It's only going to work if there's a sign there, okay? This is really high-grade stuff here, okay? So those of you that want to go running and screaming, don't do it just yet, okay? It's not time to run and scream yet. I'll let you know when that time comes, okay? I'll let you know when that time comes. But I really do like this problem because it gives you a lot of thought processes there. The big takeaway, anytime you see this, there's your answer. It's just staring you in the face. It's just staring you in the face. All right? And you just get to show how smart you are by knowing what that answer is. Okay, I'm going to finish here in just a minute. I think I'm not going to do any more. Now, here's my goal for you, okay? You have the rest of the day until 3:20 with me that you can work on homework 02, homework 03. We're going to save these last two problems and look at them on Friday. You can work on homework 01, 02, 03, WebAssign 1. Actually, you can do some of WebAssign 2 now as well. So you've got plenty of little projects you can be working on over the next hour. Goal is to have homeworks 1, 2, 3 done by Monday. 1 and 2 by Friday, 3 by Monday, and a WebAssign by Monday, okay? That's our goals right now. Have at it.